Hi, in this tutorial we are going to talk about the concept of polymorphism. Polymorphism is a concept in which we can declare something as a certain type of object and then at runtime it becomes a different type of object. And this can only happen in inheritance, so these have to be related. And the first major rule of polymorphism is that I am allowed to declare something as the parent and then at runtime it can become the child, but I can't do the opposite. So what I mean by that is I can create an object called person. We'll call it person1 equals new student Ben 17 with a student number. So I'm allowed to do that, in which when I declared it here, I'm declaring it as a person. But then once this compiles and runs, this person1 is going to become a student. I'm not, however, allowed to go the opposite way. So I couldn't say that student 2 equals new person and then etc. This would not be allowed. So going from parent to child is allowed, child to parent is not allowed. And that's kind of the first major rule of polymorphism. So let's go ahead and add some more here. So I'm going to have person2 equals new, we're going to do a programmer here, Sam 24 in a favorite language. We'll say Sam likes Python. And we'll do one more student, person3 equals new student, Kim 14 and a student number. I think I have a small typo there. Okay, so these are all legal ways because I'm starting with the parent and I'm going to the child. Remember, we have student and programmer both extend person, so I can do that with either one. So you might ask, why bother? Right? Why don't we just go ahead and call it a student from the get-go? And to me, the biggest major reason of the why bother is this power that we are now able to create an array list of people, for example, or an array, but let's go with an array list of person objects. And within that array list, I'm allowed to store all sorts of person objects. So instead of just storing person in one array list and students in another, I can put students and programmers and regular person in the same array list. So I think that's the biggest power of polymorphism. So if I say array list of type person, my people equals new array list person. Oops. And I need to make sure, because I'm using an array list, that I include a import java.util.star. Okay, so now in my array list, I can say my people.add, and I can add all these different types of objects. So that's kind of a neat thing that you can do. Now, one thing to keep in mind, though, is that they have to be related. So this would not work if programmer and student weren't children of the person class. So please keep that in mind, that you can't just randomly do this with any objects. They have to be related for this to work. So I'm going to go ahead and add one of my, let's do obj3 too, so I get a plain person in there as well. So that's kind of the first rule of polymorphism and kind of a cool thing that goes along with it. So the second rule of polymorphism has to do with calling methods. So if I were to call a method now, so if I were to say system.out.println, and I say, let's see, my student, I'll say one.greeting, right? Because a student has a greeting. If I look at the student class, the greeting for a student is, I am a great student. Okay, so when I go and I run this, it's actually going to print, barring that I don't have any other errors, I am a great student. Give it a minute to run. And while it's running, the reason that it's going to do that is because when it's declared or created, or not declared, when it's declared, it's a person, but once it runs, it becomes a student. So even though one started as a person, once it begins to run, it turns into a student, and so it would run that method in the student class. Now, here comes the rule though. Let's say I say system.out.println 2 dot, and I'm going to go into the programmer class, and you're going to see I have a method called getSalary in the programmer class. So I'm going to say 2.getSalary. And I'm going to go ahead and try to run this. And this is going to kind of show you the second major rule with polymorphism. And it says error, cannot find symbol, variable 2 of type person. So basically what it's saying is this is giving us a syntax error. And the syntax error is here because it's saying that 2, when I wrote this program, before it runs, 2 is a person. So in order for this code down here to work, getSalary has to be part of the person class. And when I look in the person class, I don't see any method called getSalary. And because it doesn't have the method getSalary, this is not going to work. So this would never work unless the person class, unless I went in and I put a method called getSalary in there. So the second rule here with polymorphism is that when I go to call a method, the method must be contained in the parent class in order for it to even compile, because otherwise it would throw an error. But then once it does start running, it will then default to the child class. So it's kind of the second rule of polymorphism. So I'm going to go ahead and just comment this out because we know that this is not going to work here. So I'm going to comment it out so it doesn't read it. So again, going back to my array list just to kind of show you the power of this now, I could now say for person peeps of my people. And in my for loop now, I could do a system.out.println of each one of those objects. And when I do it, it's pretty cool because now it's going to go through and run the toString method, right, for all of those different objects. And notice that Ben is a student, Sam is a programmer, so that one looks a little bit different. Kim is a student, so it goes back to the student one. Sally is just a regular old person, so hers looks different. So every time it's calling a different toString method depending on which type of object it is. So that's kind of why this polymorphism is kind of a neat thing to be able to add to your toolbox.